Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is GitOps on AWS, managing governance, risk, and compliance for Kubernetes on EKS. Our speakers today are Jonah Jones, who is a solutions architect at AWS, and Paul Curtis, who is a principal solutions architect at Weaveworks. Welcome, gentlemen. Thank you so much for joining me today. Sorry about that. Couldn't get that out. How are you both? Let's see. I think, Paul, you're going to be getting us started with your conversation. So I'm going to put myself on mute, take myself off camera, and let you guys get right to it.
Thank you. I'm Paul Curtis, Principal Solutions Architect at Weaveworks, and I won't go through all of the background, but I started as a developer, ended up in DevOps and then system management, and now do architecture for Weaveworks. Jonah?
Awesome. Yeah, and thanks for having me, Charlene, and I'm excited to be here. I'm Jonah Jones. I'm a Partner Solutions Architect at AWS that works with container partners. I worked at some SaaS companies prior to this, some startups for a few years. And yeah, I live in Portland, Maine. And as of yesterday, I am now a maintainer of a CNCF project called Falco Security. So excited to talk security today with you, Paul.
Thanks a lot. So I'm going to go ahead and we're going to talk a little bit very quickly what Weaveworks does and where we're going to talk today. A lot of the projects that you're going to hear us talk about and the things that we do is in the open source community. So we've developed a number of tools for GitOps and enabling your clusters to be GitOps. And EKS is a target platform for us as well as all the others. So we are a close partner with AWS and we do a lot of work, including having written EKS control for AWS and EKS.
Awesome. Yeah, and talking about EKS, which is upstream Kubernetes, we see that the majority of Kubernetes workloads in public cloud actually run on Amazon, 84% according to Nucleus Research. Next slide. And so when we talk about EKS, there's obviously a lot of domains. Today we're talking about security, and we can't really have a conversation about security without talking about our shared responsibility model at Amazon. And that just means that we are in charge of the security of the control plane, and you as a customer are in charge of security of your data plane. It's pretty simple. Next slide. But when we start breaking that down into actual terms, right, this is where we start talking about the real components. And so when we say data plane, what we actually mean is everything from the kernel of your hosts all the way to the data that's in memory inside the containers and everything in between. So policy, RBAC, package management, runtime. And AWS is really only responsible for a tiny bit, which is the easy stuff to some people. So it's the control plane, so etcd and the master nodes, right? And so why is security important? Like we talk about this responsibility model and what you have to do as a customer. And so we actually pull some data, right? We work with a lot of customers. So we see that when there are exploits that happen, that the majority of them are because of things like you have limited visibility into your container images, inadequate knowledge, and that they happen, within 6 months to small businesses, like once they get up and running. And as a small business, right, if you look at the slide, we see the average cost of a data breach is like almost $4 million. That's enough to, to bankrupt a lot of startups. So obviously security is really important, especially if you're in some sort of regulated industry. And when we talk about, like security threats, right? Again, that's not super actionable as a customer. So like in real terms, here are some of the threats like that we've seen, since EKS is launched that are specific to EKS. So, Docker Hub having crypto mining software in them. Another one, a lot of people use the Kubernetes dashboard, and at one point, I was actually able to expose cloud credentials in 2018, and that got a few big customers as well. And then, containers not being hardened in the correct way. So these are all EKS specific threats we're seeing that are different than, you're leaving your S3 bucket open. That always happens as well. And we try to provide some tools to customers to help mitigate these controls, right? And this can be anything from like the audit level to runtime security. So like control plane logging can be turned on. You can get all of those for audits. We can lock down the endpoints of Kubernetes, right? You can do private endpoints nowadays and still be able to pull images with like VPC endpoints. Authentication control using IAM or SSO. We do image scanning on push, so you can see, if there is any vulnerabilities. And IAM role for service accounts. And this is the way that you can lock down your particular pods to only have access to the services they need. And IAM role for service accounts is a really powerful tool because prior to this, I'm sure a lot of people here remember, you used to have to use Kube to IAM as a tool or just give your node general access to anything that any pod might be using on that. But now with IAM roles for service accounts, you can actually annotate that service account with a role ARN, and then that will basically be added to the pod through some Kubernetes magic that we created. And we also try to be very transparent. So in addition to like giving these controls at Amazon that are trying to take the work from the customer, we try to like let people know when we have security breaches. One of the reasons why we are strategically behind in upstream versions is because security is our #1 priority at EKS. We don't go purposely behind because we want to be 2 versions behind, but we want to make sure that all the major 0 days that happen in the first 6 months aren't getting exposed to you as a customer, right? So that's really important. So we keep this open. Anyone can actually go to our security bulletin and see all the CVEs, and if they're affecting a certain version of EKS, we'll let you know and talk about how we patch them.
So part of what Weaveworks does when we work with EKS customers is, Jonas described what EKS itself does, and Amazon provides the security tools both in container scanning and IAM roles is absolutely a necessity. But we're going to talk about the things over there on the right that say applications, right? Even with all that security that's in place and all of the tools that Amazon gives you, you still have to deploy things. And so now we're going to go through a little bit about how we deal with the application stack and how GitOps can help you do that. So just to level set, when we talk about governance, we're talking about the declared, basically the documented policy about how all data is handled, right? And that can be everything from data in a database through data that is gathered from customers. So those of you who are regulated by data privacy, both in the US and certainly GDPR in the EU, these are very critical things. And you have to have declared and written policy in order to make that work. When we talk about risk, we're talking about the liability risk, right? Because as Jonah mentioned, even on a small breach, a tiny breach of a small company, you're talking about a $3 or $4 million hit right to the bottom line. And those are the kinds of liabilities that companies cannot afford. The last topic is compliance. So compliance in the US is very much about auditing. It is being able to explain and detail exactly what occurred and when, who did it and how did it happen. So this goes along with not only users, but also applications. How did that get deployed? How did that container get there? Where did it come from? So anything that affects the use of data has to be compliant as well, not just the data itself. So a lot of companies, this is a simple slide, we're only pulling one out, but these are the 4 reasons our customers come and look at Kubernetes. And pretty much a lot of them are very common. The one that is very surprising to a lot of people is the fact that security and auditability are really key things for them. And they look at those and they say, hey, I've got to be able to do this properly. So enterprise Kubernetes in EKS by default doesn't really do this very well. Okay, it will audit things inside Kubernetes very nicely. It'll tell you what events occurred and things like that. But what it won't tell you is how the data is getting used, who's authorized to use it, who can see it, and can I put in place policy to restrict or allow certain access to data as well as the applications themselves. Kubernetes doesn't know much about that and just says, oh, you want me to run that? I'm good with that, let's go. So you have to put into place other guardrails and safeguards and auditing in order to be able to be compliant. So in order to do that at the application level, we're looking at GitOps. So a very short GitOps lecture here, or learner. The ability for you to deploy initially in Kubernetes was with an imperative tool called kubectl. However, in order to do that, you had to have cluster admin credentials to the cluster to do it. That meant that everybody who was enabled or allowed to do it had the golden keys to your cluster to do whatever they wanted. So GitOps takes that and kind of looks at infrastructure as code, but says applications as code. And in fact, it's actually any Kubernetes object that you can declare. They're placed into a Git repository, and an agent in the cluster called Flux actually monitors the Git repository for change and then deploys those application stacks on your behalf. Now I say application stacks, but that would also include anything that is declarative in Kubernetes. So RBAC is a good example. We're going to talk a little bit about this later, but any Kubernetes object, your app mesh, your ingress, whatever it is, okay? Also, if you keep in mind that if you're using IAM roles, the annotations that are on any service account would also be declared in that Git repository. So the control of what gets deployed moves away from somebody being able to type kubectl at the command line and moves to who has the ability to write to that Git repository. So GitOps basically comes down to 4 real simple points. Everything's declarative. Everything has a manifest or a Helm chart or a customized template, something. It is put into Git, a system that allows you to version them and audit them. So compliance thing number 1, every change to a Git repo is Git logged. So I can go back and find out who exactly made the change, when they did it, and what the changes were. So I can actually see the diffs of changes in the deployments in the cluster. Third thing is, rather than somebody typing a command, a container actually running in the cluster monitors those changes and deploys them on your behalf. So from a security perspective, the only person or object that has those cluster admin credentials is the container that is running the software agent that does the deployments. The last point is probably the most critical. Part of being able to monitor and observe your cluster is the ability to know when something changed. Now, we've all put in monitoring systems on various things, but this is a deployment level thing. This isn't a log. This says that I deployed a new container or changed the configuration of a container, and the agent is going to try and make that cluster look like what was declared. The key point here is that if there's a divergence or if it cannot do it, you're going to get alerted. In fact, if you really want to, you can get alerted on every change. So there's a lot of auditability that's built into this methodology that makes it very clear. So in picture form, this is a little bit busy, but I'll go through it. So a developer develops his code, he pushes his image to a registry, right? The operator then makes the change to deploy that container, and the deployment agent, Flux, is what pulls that in and actually executes the Kubernetes API commands for you. Now, there's a couple of big benefits here. One, you can have multiple clusters pulling from the same Git repo, deploying the same application. So you can do it region to region very simply. So DR becomes very straightforward. The second thing is that you can actually have different clusters for different stages of your development process. So CI versus CD, right? I want to have a dev cluster, a testing and stage. I may want to do multi-tenants. And because it's all declared in Git, you can use the source code repository to not only version between development and testing, but you can use things like branches and directories to accomplish that in a very simple way. So deployment to a production cluster becomes the same pattern that you use to release software applications. People make changes, they check them in, the code gets reviewed, it gets merged, and on the merge, those things are then deployed. So processes that you already have in place for software release become the same processes you use for deployments as well. Okay, so we talked about the four things we're going to talk about. We're going to talk about authentication and authorization and policy and compliance. So we'll turn it back to Jonah.
Awesome, yeah. And just a friendly reminder, please ask any questions throughout this. At the end, we're going to do a Q&A and answer all of the questions that we have time for. So feel free to ask. And yeah, so we're talking about authentication here. And just a quick overview, because I know these two terms are kind of confusing. Authentication is referring to who is allowed into the cluster, and authorization is referring to what they are able to do once they are in the cluster. So when we're talking about authentication, at Amazon, we have this thing called the AWS IAM Authenticator. And what that's doing very simply is it's using your base AWS credentials that are stored locally on your computer, and it's using this item interfacing with the Kube API, and it's seeing if you have access to use kubectl on the cluster. So it is a way that we can basically map the entity of an IAM user or group to a user in Kubernetes. And so that is the kind of the de facto way that we typically use this in an organization right now. And with that, right, just like looking at what this would look like in your cluster, every time you create an EKS cluster, they actually are creating this object called an AWS-auth config map. And this is basically the declarative authentication list for your cluster. So it's saying, hey, this person is able to have access to the group of system masters, or this IAM user has access to, system nodes, right? And so that is kind of how authentication is being handled behind the scenes. And when it comes to authorization, right, we can use, like we talked about a little bit with roles. So here, I know we'll cover authorization later, but here's an example of a service account that actually has a role on it. So if you see in the annotations, EKS aws.com/rolearn is the key, and the value is the actual role. So this would actually, so anything that you attach this service account to would have that IAM permission, right? And so that's kind of how it looks like in practice. And so this is that AWS auth config map that we just talked about. So here is where we would map roles or users. So if you were using assume role in your organization because you use like SSO or something or Okta, you could map a role to a system group, or you could directly map an IAM user if that's the way that your company handled giving out AWS permissions. So here, John has the group of pod admins, and we are mapping the admin user to system masters, right? So that's the person that has control of the whole cluster.
So the quick way to test anything, right, for a authentication and authorization is to actually use kubectl and say, can I do this? Now, the RBAC rules in Kubernetes are specific to things that you can do in the Kubernetes cluster itself. So, for example, create a namespace, create a pod, do things of that nature. So things that are Kubernetes API specific. This tool is a quick way to say, okay, if I have authorized John, as we saw, and he's in the right group, I can use his authentication, his credentials, and test to make sure that he can do what he's supposed to be able to do. But it also will tell you if he can't do something. So this is a nice way to say, okay, I want to make sure that John can create a pod, but he can't delete a namespace, as a good example.
I've never heard of this tool, Paul. Is this built into kubectl, or do you have to download this externally?
No, it's actually part of kubectl itself. So the ability here is it's doing based on the kube config that you have, and in the case of AWS, it's going to be the ARN and credentials. It actually tries to execute it using that user. And it just comes back true or false. It will tell you yes, no. So it's a very, very nice way to do an audit on things that you've configured. Good way to test.
That's awesome. I didn't know that.
Right. This, when you look at this, is that, remember, we were talking about imperative use of kube control to allow you to do things to the cluster. But when you get into using GitOps, you're actually moving away from doing a command at the command line, right? And so the burden of security moves from, hey, does this AWS user have these credentials on his workstation, and can he do this? Or can he impersonate somebody badly? To how secure is the repository where all the declarations are? Now, when you combine it with any repository that's out there, including code commit, what you find out is that you can have much finer grained control over what can get changed versus saying, I have one role that allows me to create pods everywhere. Well, I'm not necessarily sure I want to do that, where I want this deployment or this pod only to be created and modified by this group of people. And it may be a very small set. Whereas some people can change source code, other people may not be able to deploy that source code. So we have to look at not only the users, groups, and roles in Kubernetes, but also who has the ability to make those changes. And so by moving away from the command line and putting it into an audited, logged location, it means that some random guy can't mistype something and do something really bad, because it requires him to make the change in Git, commit that, and push it in order for it to work. And all of those things are tracked. The other thing is you can't roll back kube control, or not easily, right? What do I do? I got to go find the old manifest. You get crazy. Whereas when you do GitOps, you move the commit ID back 1 and it rolls back automatically, because the agent says, oh, the state has changed. What you're declaring is the old version. Well, I need to stop what I'm doing and start up the old version and bring it back. That also is audited, so you can know who fixed it. So they get the Employee of the Week award for that week. So we're going to go on and talk a little bit about authorization. And I'm going to talk in general about authorization in Kubernetes. So the old way was ABAC. We don't use that anymore. Pretty much I haven't seen it in dog's age. So role-based authorization controls, or RBAC, is the ability to say a given role that is defined in Kubernetes is allowed to perform certain actions with the Kubernetes API. Now, the Kubernetes API covers not only the things that you would expect, like creating pods and namespaces, but it also covers all of the newer functionality that is being brought in with custom resources controllers and operators, right? Because it applies to them as well. So if you have, if you're using App Mesh, is a good example of one that is a operation that you would do that you can restrict using RBAC. So who can make changes to that can be controlled individually. An access control basically gives you some very, very simplistic ways to approach security for authorization. So the users and groups on the right side actually are able to perform certain functions that are defined in those roles, and then they actually are executed in the Kubernetes API. In some ways, this seems backwards. It isn't, but when you start to relate for example, an IAM group to who has certain roles and certain RBAC in the cluster, it becomes very simple. You may want a developer or a tester to be able to create pods, but not delete the cluster or do not delete a namespace. So it gives you that control over the infrastructure that makes up your cluster, as well as all of the things that have been added. So an example one, this is a real simple one. And to give you an idea, this is one of the places that you would attach your annotations. So here we're saying this role called pod reader can look at pods. He can go and see them, see what's running, right? And that is bound to a particular role. Now, the annotations that allow you to do the attachment to IAM users, groups, and roles is done here. So this says we're making a map between what I'm allowed to do in Kubernetes with a group of people that are predefined in my authentication mechanisms that are built into Amazon today. That simplifies so many things because you can choose to be very simplistic and make the roles in IAM match the roles in EKS directly, one-to-one, or you can mix and match. And it really comes down to how you want to do it. The benefit to GitOps is that these role bindings and the declarations of them are visible to everybody. So they're going to know that this IAM group and this IAM user can watch pods. Now everybody else can't. So you get very, very easy way to do that mapping. But there's one other thing that is implied but never explicitly stated, and so I'm going to explicitly state it. Kubernetes, as Jonah mentioned way back at the beginning, pretty much everybody ran their containers as root, which is probably not a good thing. And we'll talk about this a little bit more, but understand that the container interface, the CRI, that runs underneath there allows you to say this container must run as a particular user. And in EKS, that is an IAM user as well. So you can do it to that level. And if I say nothing else here today, do this on everything, okay? There are few, if none, reasons to run a container as root or the application that's running in it. Okay, the only ones I can think of are very specific things, and they are very rare. It is better to err on the side of not having permission, right? The old rule about deny everyone, grant one, right? So deny everybody and allow the one user to access, for example, the database data structures, okay? Or the data files for your machine learning or whatever your data is. This is very much going to be something you want to pay attention to for compliance reasons. You want to? I'll take this one, but this is Liz Rice, who's actually works for a company called Aqua, and 86% of the images that are running in production level clusters are running as root. Okay. Now, this is not good. And if you think about it from an IAM perspective, right, a container running as root is the equivalent of system masters. So this is not a good situation. So pay very, very close attention to this and where you want this to be.
Yeah, definitely. Sorry, I had an AirPod mouse function there. But yeah, like Paul was mentioning, it's typically 2 lines in your Docker file. You got to do a user add and a user chown on the, or chown on the things you need. It's not a lot of work, and it does make a big difference when it comes to auditability and blast radius, right?
Yeah. So think of a container that's pulling from S3 buckets, right? You lock down the S3 bucket with a particular user or group. You're going to want to lock down the container application that has access to those S3 buckets with the same user or group, right? So absolutely. Some other kinds of rules of thumb here that kind of make things easier to maintain from a security. Using Kubernetes namespaces, right? Why do you want to do that? Well, it gives you instant isolation. Why? Because I can put a role-based authorization on a namespace. And that says that everything in the namespace can only do these things. So no matter what they deploy into the namespace, whatever application, whatever it is, I can reduce the blast radius really, really fast by just saying, okay, your application, it runs in the namespace Paul, and the Paul namespace can only do these 3 things, right? It can be then attached to an IAM group, right? Or an IAM role. So now I can control over time as users, new people come in and new developers leave and people go in and out. I can control that blast radius even better because I'm already doing the users and groups and policy at the IAM level, and I can just have it automatically transfer into the application space.
Yeah,
The
and
last
this one, oh,
Go
sorry.
ahead.
I was gonna say, no, this is a great point because we see this all the time. People will have 2 or 3 namespaces and they will get, not to say lazy, but they'll put a cluster role on instead of like doing 2 or 3 role bindings, right?
Right.
So they'll just give it permission over the whole cluster rather than creating the 3 role bindings needed. We see that all the time.
So the third one brings up a common pattern. So if there are services that multiple application stacks or namespaces need, put them in their own, separate them off. So like, I'll give you a good example. There may be multiple application stacks that need access to a database, right? So rather than having the database in each one of them, put the database in its own, and then you can restrict not only what runs in the database and its namespace and who has access to it, but you can also control network policy at that level as well. And it becomes very easy to see which pods in other namespaces are talking to your database, and you can be very prescriptive about which pods can and cannot get in there. So the why answer is down at the bottom because you want to be able to apply policy and authorization at the application stack. Now, I use the term application stack. That might be project, that might be the whole stack, or it may be just one set of microservices, okay, that make up one portion of a stack. But the more you do this, the lower the blast radius is, okay? And the fact that the roles are tied now to IAM means that you have a centralized location to control that policy and who can make those changes and what users and groups and applications can actually do these things. So it's really, really important. Another one. This one is very critical. And in fact, EKS makes this really simple. So if you use the container registry, it's pretty much done, right? Because policy access to the registry itself is controlled by IAM. right? So you really don't have to worry about it. In the world outside of that, where you may be running across multiple authentication zones, which does occur, you can use tools like Open Policy Agent to be a centralized policy around doing this. So if you are running in a hybrid environment, for example, you have some on-premise and some EKS at the same time, the on-premise may not be able to take advantage of IAM, in which case you can use a third-party centralized policy agent like OPA to say, okay, these ARNs in EKS and these users in the on-premise are allowed to pull images or push images. So you can do policy like that. The next two, these are universal. You should be looking at every container before it goes into your cluster. There are places to do this. One of them is you do it before the container gets pushed into the registry, right? So you use scanning tools, and there's a lot of those around. You can put it in your CI pipeline, you know, whatever your build pipeline is, and say the last thing before the push is it has to have the vulnerability check of all of the layers of the container. That's one way, but you also may consider doing it before it actually gets run in the cluster. And the way you do that is with an admission controller. In the cluster, you declare it and say that every container that gets pulled for run has to pass through here. And if it fails, it's not started. The other one is a little bit different, and I push back a lot sometimes as a developer. I'm like, I don't want some source code scanner. It's like, it is now kind of automatic. You have to lint your code. I just, you know, the old days we used to do it like on paper, but not anymore. You really do, because there's so many little things that you can miss. And the other thing for those who have outsourced development teams, this is absolutely critical, right? So you want to make sure that you're doing source code before the container is created. Then scan the container so that in case it pulled in layers from different places that aren't cool, you want to trap that. And then you want to have going into the cluster saying, I'm only going to allow containers from this registry, or I'm only going to allow containers that have been authorized in this manner. So you can put a lot of things in place to catch what potentially could be huge disastrous breaches long before you get there. I'm going to let Jonah talk a bit about secrets in a second, because this is one that always comes up. Last one in a generic sense. Node level network policy, people use it. Not so much applicable in EKS because you really don't need it. On premise, it's much more common. Kubernetes network policy between namespaces and RBAC doing with that is pretty common, actually. So now you get into mesh and policy and mesh application policy. App mesh does this really well, really, really, really well. So pay attention to this, because for the most part, it is a much simpler and easier to define and audit mechanism is to capture network policy and user application policy at the mesh level, rather than trying to do it between the pods. And I'll give you the simplest reason why. What happens if you have to scale the cluster? Right? All of a sudden you're like, okay, does it apply to these newly scaled node groups that I just added? Well, yeah, it should. Well, if you're using GitOps, it will. But the point is that you have to pay attention to it. Whereas at the application and the mesh level, that rule will apply because the mesh is running independently of the containers it talks to. So there's reasons to have both. Though I have seen customers definitely who have network policy in place because that's their corporate policy, and that can be done as well.
As of a few weeks ago, too, we just released security groups for pods as well. That's now live.
Right. And that's a huge, huge thing because it moves the pod security policy into the realm of users and groups that have already been defined and centralized. So there's a couple of really nice ways to do that. Yeah. And let's talk a little bit about secrets management.
Yeah, we get a lot of questions about secrets, and we don't have a definitive solution necessarily at AWS, but it is something that we are working on. And so I'll give you some talk about like what we recommend for secrets and maybe some of the advantages and disadvantages, and then just like a little tidbit from what we're seeing in the industry here. So there's a secrets manager controller POC that's being developed by some internal container folks right now. That is open, and you can try that out. So that's using secrets manager as the back end. It's still in beta, so again, it's a POC. Sealed secrets is another great alternative by Bitnami, which is storing them on cluster. Some people need external secrets for compliance reasons. So, in that sense, there's also another tool developed by GoDaddy called Kubernetesctl secrets, which is going to be similar to the secrets manager controller PLC. Obviously, Kubernetes has some built-in secrets functionality. It stores them, and then they get put into pods via environment variables or files. But one interesting thing that we're seeing from the field is that as of about 2018, we're starting to see a big shift towards people volume mounting secrets rather than using environment variables. And it's not 100% obvious why, but if you take a look at so the way that containers work is on the node, there's this thing called the /proc directory. And that's actually using some of the information about like the namespaces on the kernel. And if you were in there on the node, you could actually see the environment variables from the node that are in the container. So if a bad actor was able to get into your node, they could actually see the secrets without ever logging into the container. So that's why we're starting to see this shift of people using volume mounts rather than environment variables. So that was just a little kind of interesting thing we're seeing from the field I thought I'd share as well.
And the thing for using a tool like sealed secrets, and actually external secrets, this works as well. So you can use GitOps to do this because you can declare the secret and put it into a Git repository. And the first thing everybody says, well, they'll see the secret. Well, no, it's encrypted. So what goes into GitOps is an encrypted version of the secret. It's mounted into the container via volume. And therefore, even if you got all the way through and the bad actor got all the way down to the node, he still has to decrypt them, and he can't do it without the private key. So in the case of sealed secrets, that's in memory if he really wants to go digging around to find it. In the case of the external secrets, either with Secrets Manager or with GoDaddy or with Vault or any of the other tools, those private keys are stored outside the cluster. So in all cases, what you put into your declarative statements for the cluster are completely encrypted at that point. So you really can't get very, very far. Okay, so we're on to our last topic, and this one goes pretty quick, but we'll talk about policy. And I'm going to talk to policy in a very general way, but I want to show you where some of the choke points are, where you may want to implement policy in various different parts of your build pipeline. Now, we've talked about most of them, so we're just going to talk about them and kind of lay it out as the whole picture. So when you look from left to right, you have the developer all the way on the left and you have the cluster all the way on the right. So for the cluster, for the developer, he has to be able to obviously push code. So he needs credentials to that repo. Okay. The build machine, whether it be him or an actual build pipeline like a Jenkins or something like that, they're going to have the credentials to push the images. Okay. Then when you get to the container registry, there's another set of credentials. All right. Now you'll notice this one thing about this is typically you see these credentials are all over the place, right? So for the developer to get his image all the way to the container registry, he actually has to have 3 sets of credentials, perhaps 4. And most InfoSec teams really don't like having that many credentials out in the real world. So when you look at a GitOps pipeline, what you're doing is you're breaking it up so that there's no human intervention required. So the developer only needs his Git credentials. The build process only needs the container credentials, and the container registry credential for the push is for the developer or the build pipeline. When you get all the way over to the cluster, nobody needs anything for the cluster in this pipeline. Whereas in the one prior, the developer, to be able to deploy his application, needed cluster admin or an equivalent role. Here, because the agent runs in the cluster, it means that he only has to be able to hit the config repo, or an operator only has to hit the config repo. And what you'll notice is nowhere in this picture are the cluster API credentials outside the cluster. So it immediately changes the policy, right? So I can stick policy in a couple of different places. First one is the operator, can he write to that repo and make changes to the deployment in the cluster? And if he can, I now have auditability at that point. So I know exactly what he did and when. So you can apply policy, as we mentioned before the container registry. Let's check the images. After the container registry, before the cluster pulls it, right? In the meantime, the dev is writing his code and building his stuff, and the build pipeline is picking it up and doing CI, right? But in no time do you see that is one person in this picture, or one process in this picture, has all of the credentials to everything, and none of them have credentials to the cluster itself. So that auditability means that you really have to try really hard to do something bad. Okay, so we get to the final part of this, right? Where's the compliance part? Well, one of my jobs as a developer is I worked on Wall Street, and I was writing applications for the currency trading desks at the former Merrill Lynch. And compliance back then was non-existent. Now it's very, very highly regulated. And mostly they're looking for fraud and things like that. But the point is that compliance is something that every company is worried about, because there is a financial risk involved. There's a business risk if you are not compliant, especially in regulated industries. Healthcare, financial, okay, are the two biggest. Pharmaceutical is another one. Insurance. All of these industries have to have compliance. So when you're talking about Kubernetes, you can see we just spent 45 minutes talking about lots of different things that you have to pay attention to. So my statement is this: if you've actually reviewed what we said and used the tools that you're given with EKS and Kubernetes, you basically are likely to be compliant. The company that I'm going to use as my test case is Metal. Very simply, this is the business banking for NatWest. They're all a GitOps shop, and basically this approved made it all the way through their internal audit and compliance without any problem, because everything had an audit trail. The authorization was in Git. They had already defined those as it passed muster already. They didn't have to bring in a new policy, a new process, or a new procedure for vetting. And all of a sudden it went very, very quick. And some very nice things that happened. The key one that I love is their mean time from 0 to up and running cluster fully populated in EKS is 20 minutes. So they can go from 0 to full production in 20 minutes. And if nothing else, that is an enormously powerful thing. So now we'll go over to the question panel. Let's see, there is one. Nope.
I do have a couple questions here for you. Looks like we have one that has come in. Let me turn my camera on so everybody can see me. The question is the GitOps agent at cluster level, or can it be at node level?
So the GitOps agent, it is at the cluster level. It's controlling deployment into the cluster API. is remember at the node level, it's the kubelet that's actually executing the processes that run on the physical node. So if you secure what is allowed to do that and you deploy using the API, that will give you that same level of security. If you needed to do process level things on a Kubernetes node, okay, those are going to be things that you're going to do at the node level, and they're going to be done using the standard Linux tools. But remember a couple of things, what the kubelet does. In Linux, it creates namespaces, and it creates network interfaces that are attached to those namespaces, and then it runs the containers in them. So C groups are created, so it's automatically isolated. By the way, that's how it limits the resources too. So you would have to really do some really breaking stuff to the kubelet in order to break out of that. The second thing is that the communications between the control plane and all the kubelets in the cluster is all encrypted and certificate authenticated based. So you would not only have to have the cert, but you'd have to break the SSL as well in order to get in there. And it's really, really hard.
All right, great. Here's another question for you. If I use a private cluster, do I need to set up a private registry?
So the answer to that one is no. So you can use what are called VPC endpoints if you have a private cluster, and that will allow you to get access to other AWS resources without opening up your cluster to the internet.
All right, great. Plenty of time for questions. Well, a couple minutes for questions, guys. So if you do have one, go ahead and submit it, and we'll try to get to as many as we can. Here's another one for you. Let's see, for what industries is this applicable?
Wow. Let's say all. The primary uses for all of these tools and the way you set this up are typically any regulated industry: healthcare, insurance, financial, pharmaceutical, and that's in the US. In Europe, it's every company, because in order for you to be compliant with GDPR, truly any access to the data has to be compliant, right? Because you have to know and be able to reproduce it. And so, yes, you're going to want to do these kinds of steps, especially about what applications are running in the cluster in order to be compliant there. But definitely at the data level, it's super critical.
Right.
Yeah, and earlier we talked about that $4 million like average security breach stat. A lot of that comes from the compliant industries. Like if anyone's ever seen what a HIPAA fine looks like, it is not small.
No, and the types of breaches that we see for things like in the US, PCI, and PII compliant applications, so credit cards or billing or payment services, things like that, all would fit into this. Even the little ones, right? If you're running your pizza website, and you do online ordering for your pizza, you come under those regulations. Really, really simple. So, hey, I'm selling my sweaters online. Guess what? If I take their money and it passes through my hands, I'm bound by those same regulations. Lastly, I'm going to say, once you set this up, it becomes automatic. If you do it at the beginning, it becomes a lot easier. So if you pay attention to especially RBAC in Kubernetes and the roles that you create that are allowed to do things, users and containers, if you do that up front, you've hit most of the real big breaches. So just make it a part of a thing that is every container that I run out there, and everything that I'm doing in my Kubernetes cluster has to look like this. Just don't worry about it. No more questions.
Okay, all right. I think we have time for one or two more questions here. How often can we have the deployment if we do not need it for every commit? What parameters need to be considered?
So the question is this. I'm going to answer it this way. If you make commits, like 20 commits in an hour, okay, one of the things the software agent does is it actually does not really just rebuild the cluster. What it looks for is changes. So if you have 20 commits and if you've changed no deployment parameters, like none of the manifests are going to require a restart of a container, it won't do it, right? So it actually looks for differences, and it only applies the differences. It doesn't apply everything. And I hope that answered that question.
Okay. All right, let's do one more and then we'll close it out. Mentioned security groups for pods. I assume that's working with the AWS CNI plugin. Does it integrate with other tools like Calico?
So Calico is using network policy enforcement. So it does not currently work with Calico. However, you could have the two layered together. It is using the IPAMD part of the VPC CNI plus a mutating web controller to actually do the work behind the scenes.
All right, great. Well, we're about 4 minutes to the top of the hour. So unfortunately, that's all the time that we have for question and answer period. If we did not get to your question, I apologize, but please know that the folks at Weaveworks and AWS will be getting a copy of all of the questions that came in. And I'm sure somebody from their organization will be more than happy to follow up with you offline and get your question answered. Also, a quick reminder to the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look at the on-demand section, and it should be right waiting for you. Okay, I did mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's get to that. Our first winner today is, this is Jonah's favorite part of the webinar every single time.
I wish I could be included.
Yeah. Right. Okay, our first winner today is Jordan G. Congratulations, Jordan. Our second winner today is Carl with a K, R. Congratulations, Carl. Third winner today is Monica R. Congratulations, Monica. And our fourth and final winner today is Tim Yu. Congratulations, Tim. We'll be following up with all 4 of you via email following today's webinar to get your gift card over to you. So please check your inbox. If you don't see it there in your inbox, please check your spam folder. Jonah and Paul, great presentation today. Love the slides, love the conversation, and judging from the questions that came in from the audience, I know they got a lot out of it too. So thanks very much for your time, your expertise.
Thank you.
Yeah, thanks so much for having us.
Yeah, as always, yes. And also I want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm now signing off. Have a great day, everybody. Please stay safe.
Thanks.